So hi guys, I hope my screen is visible to you all. So today we will discuss an important topic, that is links in Linux. Okay. So basically what are links, guys? So link, you can consider in general, what is a link? So you click on a link and you are redirected to another location. That's what links are. Okay. So in Linux also we have concept of links. So basically are soft link and hard link. Okay. So let's discuss first what is soft link, okay, and how we can create it. So I have already created the notes so that it doesn't take much time. So let me explain it. Okay. So soft link, I hope my screen is visible. So soft link is also known as symbolic link or symlink. Okay. And it's like a shortcut to another file. For example, in Windows you have your desktop shortcut. Okay, you click on original location is something else, but on desktop you have the shortcut created for it. Okay. So basically, it points to the file path and not the inode. What is this inode? So basically, every file and folder has a number attached to it in Linux. So I will discuss it and show you practically also. There are, okay. So it directly points to the file path and not to the inode. Okay. And if the original file is deleted, the symlink becomes broken link or dangling link. This means if we delete the original path of which we created our soft link, then the link will no longer work. Okay. And this is the command to create launched an EC2 instance, and currently I am inside my Linux server. So let me perform the actions as a root user. Okay. So right now in this location we don't have anything. So maybe let's create a file inside OPT folder. So let's go cd slash. Let's go to the OPT folder. Okay. Inside here, let's create a directory, my directory, and go inside my directory. And inside, let's create a file and paste some content. Okay. File one inside file one. Okay. So simply I have created a file in this location, in OPT location, in OPT slash my directory. I have created one file. Inside of this file, I have pasted this content. Cool. Now let's move ahead. Now I want to create a soft link of this file one, this location. Okay. This is our root location. From here, I want to create a soft link so that I can access this file one directly from here. So for that purpose, we will create soft link. So I already told what was the command for soft link. ln space -s means soft link. Source file and destination, not destination, source file and name of your soft link. So what's the, where is our source file? It is in /opt/my directory, and the name was file one. So for this, I want to create a soft link, and the name of the soft link is, let's say, soft. Let's name it soft link only. Okay, my soft link. Good. Press enter. So now if I do ls, so basically you can see my soft link got created. Now suppose anyone wants to access that file, simply instead of going there, he will directly access the file from here. Okay. So this was about soft link, but sub this location, then this soft link won't work. Okay. Why? Because the inode number is different. Let me show you the inode number. How do we check the inode number? So s ls space hyphen li. Yes. So you can see if I do ls space hyphen li, first you will see that my soft link is pointing to this location, and this is the inode number. 3705 is the inode number. Okay. Let me show you from here also. ls space hyphen li, inode number I'm checking for this file one. So the file one's inode number is 6478. The inode number here is 3705. This means that both locations inode number is different. Okay. It's just a shortcut to access this file, nothing else. Suppose I delete this. Suppose in Windows also, if you delete your original file, suppose you're on that location, you delete the original file and you don't delete the shortcut, and then you try to access that file by shortcut, will you be able to access that? No, right? Similarly, here also, you will not be able to access it. If I delete this file, I won't be able to access it. Now let me see. See, first of all, your soft link will become like this, red. This means it's broken now. Okay. And if I do ls space hyphen li, so see here, my soft link, it's red, and here also it's in red color, means this location does not exist. If I try to open it from here, no such file or directory. Okay. Now let's move to hard link. In the end, I will show you how both are different and what inode number is. Okay. So basically here the inode number was different. Okay. it doesn't point to the inode. We saw that. Now things will become more clear once you understand about hard link. Okay, so a hard link is like another name for the same file. Okay, basically you can say it's a real-time copy of your. It's a real-time copy. This means that if you make a change in one file, it should be reflected in other file also. Okay, how this happens? Because the original file and the hard link both point to the same inode. Okay, so basically let me show you practically now. Okay, things will become clear then only. Theoretically you won't understand. So let me go to the same location and create another file. What was the location? cd slash opt slash my directory. Let's go here. Currently we don't have any file, so let's create another file, file 2. Inside it, inside file 2. Okay, good. Now I want to create a hard link, not the soft link. I want to create hard link for this file. So let's go to the root directory only. Okay, so here the command is ln and the source name where your file is. Okay, so my file was where slash opt slash my directory, and the name was file 2, and name will be hard link. You can give any name. I'm giving hard link for the sake of understanding. Okay, enter, do ls. See, a hard link is created. Do inside file 2 we can access the same content. Good. Now let's see if the inode number are different or same here. So what was the command? ls space hyphen li. So ls space hyphen li. You see what is this? 6478. Okay, now let's see what's the inode number for this one. 6487. So the inode number for hard link is 6487. The inode number for the original file is also 6487. So this simply means that using hard link, what is essentially happening is, so suppose this is the inode number. What was it? So 6487. What was that? Let me check. 6487. So let me show you. For example, 6487 was the inode number for our original file. Suppose this is file 2. The file 2's inode number was 6487. When I created a hard link in my root directory, in slash root, when I created hard link, so this was not the exact copy. Basically, it just pointed to this inode number only. Okay. Suppose I create another hard link. So this another hard link will also point to this inode number. And if I change something here, the changes will be reflected here. Suppose, let me create another. I have one hard link here. So let me go to, let's go to the home directory and let's create a hard link here. Currently, we have only EC2 user here. Let's create a hard link for, again, for the same file. What was the command? ln space. What was the source? opt. So like this, you will have to go slash opt and my directory file 2, create a link, and the name of this is let's name it hardlink 2. Hardlink 2. Okay, enter. So hardlink 2 is created. Let's see if we are able to inside file 2. And what's the inode number? So inode number is 6487 for hardlink 2. Focus here. Hardlink 2's inode number is 6487. Right now. So if we see this diagrammatically, basically I created inside my slash home directory, I created hardlink 2. This hardlink 2 is also pointing to this inode number only. The inode number is same. Now suppose I make a change here. So let's see the changes are reflected elsewhere or not. Suppose from the home directory only I am changing. So line 2 added. So I changed here. I'm able to see line 2 added. Now let's see in the root directory, our first hard link was there. Let's see if changes happened here or not. See, here also changes took place. And similarly, if you would go to the original location here, so let me show only. This was the original location. If I see here, here also changes are reflected. Okay. So basically, all of them are pointing to the same inode number. Suppose I create hundreds of hard link also, then also I can parallelly, make a change in one place and it will be reflected in all the 100 hard links also. Okay. But the interesting point and the main purpose of using my file, suppose I delete this one, I delete the original file only, I delete. Okay, then also we will be able to access, because inode number will still be there. Okay, the inode only, see, we are only able to see the file names and folders names. Okay, but Linux internally stores this inode number. Okay, it's maintaining somewhere else. Okay, it's maintaining this inode number somewhere else. Okay, so even if we created hard link for this inode number, so if it's deleted also, it will be pointing to this only, right? Yeah, so let me show you. In SoftLink, if I deleted, I was not able to access my files. In HardLink, let me delete the original one only. Okay. So file 2 is deleted. Let's verify. If I do cat or ls, so no such file or directory. But I have my HardLink with me. If I do cat HardLink, see, they are still accessible or not, right? So this is the main benefit of using HardLink. Okay, even if your files or folders are deleted, then also you can access it. So the main real-time use case of HardLink is that instead of making a copy of our files and folders, we can directly point it to the inode number, and it will back it up without wasting any extra space, right? So this was about, if the original file is deleted, the link will be broken, but in HardLink, the link will not be broken, and you will still be able to access and use the file. Okay, and one file can have multiple hard links and soft links also. Okay, and how can you check? So basically you can use a command. Okay, stat, and let's see, stat hard link. So currently you can check how many hard links are there using stat command and your file name. So if you check here, see, two links are there. Remember, one original one we deleted only, so hard link one is there, and the second one in the home directory. If I create one more hard link, suppose I create hard link 3 here only. Let me see if the command is visible. Yeah, so this command, if I, oh, so file 2, since it's deleted, we won't be able to create. We can create hard link for hard link also, right? Because it's, see, basically it's pointing to the node. Okay, so I want to point uh, another hard link to node. Okay, from this location only. Suppose I created a link called Raj link. Okay, and I'm pointing it to, basically in the source I'm providing this hard link. This hard link is the node number it's pointing to is 6487 only, no? So basically if I do this thing, ls hard link and Raj link, or not ls, sorry, ln, no? If I do this, so basically Raj link's inode number will also be same only. The ls space hyphen li, inode number is same, right? This means this is pointing here. Raj link is also, I created it by this hard link in this location only, but this one is also pointing where? Here only. I hope you are understanding what I'm trying to say here, right? So now if I do stat command here, let's see how many links I do have now. Stat hard link. So see, 3 links are there. Stat Raj link, 3 links, because 3 pointers are pointing to the same node, right? So that's why 3 links are showing here. Okay. So this was all about hard link and soft link. Okay. So I hope you understood. And inode also is a very important source data about all the files and folders you have in Linux. So Linux internally maintains all the metadata, like what kind of file it is, what's the size, okay, how many hard links are associated with this. So that is maintained via inode. Okay, and inode number is, this one is inode number. Every file and folder in Linux has a unique inode number, which you can check by using ls-li command. Okay, so see, this is the inode number. If I move one directory ahead, so here we have these many files and folders. Here also, if I do ls-li, here see, these numbers, these all are unique numbers that Linux uses internally. Okay, so I hope you got the clarity of what soft link is and what hard link is. And in the real time, hard link, as I told, it's mostly used for backup purposes. So for creating real time point in time backup, we use hard links. Okay, and soft link, the main use case is for directories deep, like opt inside mkdi, my directory, inside there is another directory, inside there is another directory, and there is your file. If you want to provide, if you are daily accessing that file, so you can create a soft link, okay, in your root folder and directly access that file. Similar to the desktop shortcuts. Okay, remember this. Soft link is similar to desktop shortcut. Okay, and hard link, files, large log files. So instead of copying the whole file and storing it, it will unnecessarily take more space. We can use HardLink concept. Basically, we can point our pointer to inode, this inode number. Okay. So that was all about SoftLink and HardLink. I hope you got a clear understanding of what HardLink and SoftLink is, and I would recommend you to do this practically. So these are the commands. For here you have just to use, you just have to use a flag -s, and here you can directly use ln. Okay. So that will be all from my side, and we'll meet again in the next lecture.